So in our last lesson, which I don't know when you watched it, maybe it was 2 minutes ago, maybe it was a day ago, maybe it was a week ago, but in our last lesson, we learned how to derive e to the x and ln x. And that would have required a little bit of work because before we even started that, we had to talk about what e is. So quick recap again, e is a constant. It is 2.7 something. You can find it on your calculator. There's a button on there, right? It is right here. This is e. It is a constant. It's kind of like pi. You know how pi is 3.14159? It's a completely irrational number. Now, pi looks irrational because you can see all these digits are changing. E looks like it's repeating. I promise you it's not. That's just as far as it happens to look right now. But e should be an irrational number. And it's one of our main constants. And the biggest reason why e is so useful is that it derives to itself. E to the x, its derivative is itself. And I kind of like this comic here. If you've ever seen Foxtrot, he likes to use a lot of math things on there because hopefully you can kind of picture this together. I don't want to spoil the joke. I haven't done it yet, but this 2.7 number right here is then e. R squared would be 2 r's. 1 over y to the minus 1 is just regular y. This will just be x, and then force over acceleration is known as mass. So it's Merry Xmas, Merry Christmas. So. But now you'll get it because hopefully you'll now know that 2.71828 is the number E, not the letter E. E is a number. Boy, if there's something you can take away from last lesson and this lesson is that E is a number. So what we'd like to do now is figure out how to derive an exponential function. One of the things that I showed you in our notes here is that we need to try to figure out how to do y equals, like, say, 2 to the x, or y equals 3 to the x. We have to figure out how to derive those ones. And so I'm going to show you the proof for that one now. So the way we're going to do this is we're going to take the natural logarithm of both sides. So one thing you've learned in your math class is you should be able to add a log onto both sides. Well, I'm not just going to add any log on. I'm going to add on a log with the base of e in the corner. Remember how log with the base e in the corner is actually a log? The reason why that's useful is now I can pull down in front this x, and it would give me the ln of y equals x times the ln of b. And b, by the way, is an unknown constant. Like, this is 2 to the x, or 3 to the x, or 4 to the x. We don't know what number b is, but we know it's just a number like 3 or 4 or 5. Okay, then we're going to do implicit differentiation. So that means we're now going to take the derivative of both sides. So I'm going to take the derivative of ln y, and then I'm going to take the derivative of x ln b. Well, ln y, we just learned the derivative of ln is 1 over, so it'll be 1 over y times dy over dx. Right? Because the derivative of a natural logarithm is 1 over x, but we have y, so it's 1 over y. But then since we didn't use x, we used y, the chain rule or implicit differentiation is going to throw in a dy over dx, which is good, because we need that anyways, because we're solving for this. And then this one here, this is the one that throws most kids off in this proof, because they're like, whoa, what's ln b? But don't forget, this is just a constant. So this is like 2x. Well, if you derive 2x, it's 2. Right? This is a number, only it's a irrational logarithm number. So its derivative is actually ln b. The x basically goes away, and ln b is what you're left with. Last step, I want to get dy over dx by itself, and so it's going to be equal to y ln b. And then for our last step, I'm going to go way back up here, we just said y is equal to b to the x. So then it's actually b to the x ln b. This is how you derive an exponential equation that is not an e base. I think I have the rule sitting here. Maybe I don't have the rule sitting here. So if you want to take the derivative of like, say, 2 to the x, the derivative of 2 to the x is actually 2 to the x ln 2. That's how you find the derivative of it. Is whatever this number is right here, it actually goes into 2 different locations. And this b right here is actually just a value. So now I've done the proof for it. Let me work you through the examples to build our way up to it. So first, let's do this one here. How do you find the derivative of e to the x? Well, we've learned yesterday that the derivative of e to the x is itself. If the base is e, 2.7, etc., then it derives to itself. Right? Which then means, well, what happens if the base is not e? What if the base is 2? Well, now we know the rule for this. Right? The rule for this is that when we take the derivative of 2 to the x, it's going to be itself with an extra ln 2 on the end, because that's the base. But this guy right here is a product rule. We're going to have to do this properly. So to find its derivative, we'll go first times the derivative of the second plus the second times the derivative of the first. Okay, so 5x just stays 5x. That's pretty easy. 2 to the x, we've now learned, becomes ln 2 to the x. And then for the last one right here, the derivative of 5x becomes 5. Now on this one here, I'm going to want to clean this up a little bit just so that it looks nicer. I actually put those in a different order already. Why don't I put my 5x then times by 2 to the x, and then times by ln 2. That seems to make a lot of sense. Another thing you could do, by the way, is you could pull this up top. So maybe you could do like 2 to the x. You could do ln 2 to the 5x. You could pull, like, say, the 5x up top as the exponent of the 2. But leave this 2x sitting right there if you want it. Like that's something you could do if you'd like. And then for this one right here, definitely change the order. I would go 5 times 2 to the x. And do not make that 10x, though. Hopefully you know your exponent rules well enough to know that this right here means 2 multiplied indefinitely, then times by a single 5. That is not the same thing as 10 multiplied indefinitely. So, yeah, here's a couple different ways we could write our answer. Oh, wait, rewatch that if you need to. Try it again. I'm going to move on to another one here. Because, yeah, when you're watching with a video, right, you can always just slow it down. And if I go too fast, you can pause it yourself. So, let's try this one. This one is hopefully clearly a quotient rule. We need to do division. So the rule for a quotient rule is to find the derivative. It is the, let's get it right here, bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, I have 2 derivatives I need to take, plus a little bit of cleaning up I need to do. This right here is going to become 6x, and I'm going to put it in front of the 4 to the x. And I want to make sure that I'm really clear that it's not going to become 24, right? So I'm going to put the 6x maybe in like a bracket there. Or another option, actually, would be to do 6x bracket 4 to the x, just to make sure that it's clear how those two are separate. And then for this next little bit here, the derivative of 4 to the x is 4 to the x, but then times by the ln of 4. And that's not bad in terms of the way I wrote it. Remember, ln 4 is just a number. So, I mean, there's a few different ways that we can clean that up in a second here. The last one here is that this is actually going to be 4x. And then remember the rules for this one right here is that you need to, like, if you have x to the power of 2, that means that you're multiplying them. So this is actually 4 to the 2x. Hopefully remember your exponential rules, right? If you have 2 to the 3 to the 2, it's actually 2 to the 6. Right? You take the 3 and the 2 and you multiply them together. So x times 2 is actually 2x. So I'm going to clean this up one little bit more. What I could do here is I could maybe take this ln 4, maybe throw it more towards the beginning. So I could go 6x, 4 to the x, minus 3 ln 4 times by 4 to the x times by x squared. I could do something like that maybe, just to make it really clear as to how all these things fit together. But I actually have a way better idea here, because I want you to notice these. Maybe the best way to organize this one now, and again, you should always ask your professor at university what exactly they're looking for. because there's actually something that cancels here. And I hope that you can see this one here. I'm just I'm messing around for the sake of messing around with how I rearrange things. But hopefully you'll see there's a 4 to the x in both of these terms here. So I'm going to factor out that 4 to the x. And it's going to leave me with 6x minus 3x squared times by, oh, I need to clean that up a little bit there, 3x squared ln 4. I'm just kind of changing that out a little bit. And then, you know how I wrote this one as 4 to the 2x? But I could write it as 4 to the x times by another 4 to the x. And the reason I want to do that is I want you to see that one of those gets canceled. So this is the answer that I'll be expecting. I do need you to do a little bit more work cleaning these up than before. You should always ask your professor or your marker, or whoever's marking stuff, what they're expecting. But I would expect that on this question here, that you would have caught that there is a 4 to the x in all of these terms here, so that it can be canceled. And I mean, in terms of my expectation otherwise, like when we were doing our original product rules and quotient rules, I didn't really care that much then, because I didn't see much purpose to it. But here, there definitely was a purpose. The rearranging allowed us to be able to do some canceling. So I need you to be fairly familiar with how to rearrange your logarithms, because there's actually one more thing you could do. Now, this is a little bit silly to do this, but you could go 6x minus x squared ln 4 to the 3. And you could bring up the 3 right here. You can just selectively bring up the 3. Because then you can make 4 to the 3 equal to whatever that is, which I'm pretty sure is 64. So you could make that a 64 instead. All of these would be valid, but at the very least I wanted you to cancel the longs. Okay, hopefully that one made some sense. If not, rewatch it again, or better yet, ask me questions. Make sure you ask questions, okay? You have to advocate for yourself and ask more questions. Okay, last thing. We also need to learn how to derive a log function that doesn't have a base of e. Remember, if we do log base e of x, well, we just call it ln. But what happens if this base right here is an e? What happens if it's base 2? Or what happens if it's log base 3? Can we do these ones as well? So I'm going to show you this one in a proof now as well. What we're going to do here is we are going to convert it back into exponential form and then implicitly derive it. So if I convert it back into exponential form, it becomes b to the y equals x. And then I'm going to take the derivative of both sides here. Well, b to the y, we've now learned the derivative of that is b to the y ln b. But then we also need to take the derivative of the baby, which is the extra dy over dx, right? Because this wasn't x, this was y. And this is equal to 1. So, when we want to isolate for the dy over dx, I'm not very good with my pen today. I need to divide this stuff to the other side. So it means that my dy over my dx will be equal to 1 over b to the y ln b. But one more time, b to the y, we way back up here before I derived it said b to the y was equal to x. So this is actually 1 over x ln b. And this is how you find the derivative of a non-e derivative, right? Like if the base is e, then you can just go 1 over x. And actually, that's something I want to point out here is, let's say that it actually was log base ex. Well, its derivative then, according to this rule, would be 1 over x ln, and then your base, well, your base was e, so ln e. But ln is log base e of e, and like log base e of e would just be equal to 1. So all of that wouldn't really matter, which explains why ln of x derives to 1 over x. So, long story short, I have a new rule for you. Actually, I have 4 rules for you. Here are the rules that we learned in last day's lesson. E to the x is e to the x, ln x is 1 over x. And then here are some new rules. What if it's not b? Well, if it's not e and there's like a 2 right here, it's 2 to the x ln 2. If this is a 5 right here, it's 1 over x, but then you have a ln 5. These things are very similar to each other, except in both cases, there's a natural logarithm of the base that's required. If the base was e, it wouldn't have mattered because ln of e is just 1. But ln of 7 will slightly change it. So let's try an example. We're going to find the derivative of this guy right here. And this is going to require a chain rule. Because to find our derivative... Okay, so it's going to be 1 over x. Well, our x is actually 2x minus 7. And then we still need the natural logarithm of 2. And then after that, we still need a chain rule, which means I need our derivative of 2x minus 7. So our final answer here is actually going to be 2 over 2x minus 7 ln 2. Hopefully you're able to follow that. This is the 1 over x bit right here, so 1 over x, but x is actually 2x minus 7. But then you need the addendum of the natural logarithm of your base, which is ln 2. And then up here, well, since this thing wasn't x, it was 2x minus 7, we need to derive the 2x minus 7. So there we go. Let's try another one. What about 2x ln of sine x? Now here's where we start getting a little crazy, because this is almost to the point of being ridiculous. Who ever needs to derive this function? But it's more of a mental activity now. So the first thing we need to recognize is what rule do we need? And I'm going to separate this using a highlighter right now into 2 different sections. Because hopefully you can see that here are our 2 sections. We actually have a product rule. So I'm going to start with our product rule first. First times the derivative of the second plus the second times the derivative of the first. So we have two differentiations that we need to do, right? We have to do one right here and one right here. And one of them is really easy. Unfortunately, the first one's hard. The first one is the derivative of natural logarithm. Well, a natural logarithm is 1 over x. But then we would have to chain on the fact that it wasn't x, so we're going to have to take the derivative of sine x. And then over here, this one's really easy. The derivative of that is 2. So, okay, well, a little bit more cleaning up here. You've got 2x times 1 over sine x. And then you do the derivative of sine, which is cosine. And then here, why don't I put the 2 in front and go 2 ln sine x. That'll work. Now, we are done here, but there's a little bit more rearranging I could do. I could call this 2x cotan x, because sine underneath the cosine is cotan. The other thing I could do here is I could take this 2 and I could throw it in up as the exponent of the logarithm and make it sine x squared, which means that I could write it as ln of sine squared x. Right, throw the 2 up as though it's up here, but then when we write it in this notation, we actually put it in between the sine and the x, and so this would be a good way of writing our final answer. Now, you didn't have to put the 2 up top. You could have put the 2 back down here. That'd be fine. You could even factor out the 2. One thing I got to point out, though, is that look at what I have right here. Now, I didn't draw it the nicest, but it almost looks like it's 21. So you got to be really careful with your 2's, because you want to make sure that it's very clear that's a 2, and then it's ln, ln. I'm not very good with my board today. Don't let someone think that it's 21n. Okay, one thought I had as I was working on this. We're at the point in calculus right now where if you have not been following along lesson by lesson by lesson and working your way through, there's a lot of steps where I imagine that, oh my goodness, your mind is going to be like, what just happened? And so if you're not building block by block by block and building your tower of skills in the right order, and you're just trying to hop right in, you're going to struggle. And the reason I want to point that out is, again, one of my goals is to just help you guys get ready for next year. The point I want to make is don't skip class. When you're in university, there's no attendance, there's no accountability. You come and go as like you're in charge of yourself. If you were to skip a day, I promise you, it's not just skipping one day. It's like missing a whole bunch more. Because if you didn't know how to deal with cotan or logarithms or 2's getting brought up top and all of the previous rules, you would be so lost. And so I think this is a really good example of how you need to make sure that you are there and paying attention and ready to go every single day building on your skills. And if you don't get something and you have a question, you need to figure out the answer to that now. You can't wait a week and be like, I'll just get to it later, because it builds. So, I mean, if this is you in university next year and you missed something, you need to find your professor, or you need to go to your tutorial person if you have one, or you need to get a study group together, and you got to find a way to answer your questions immediately so that you don't get further and further behind, because you could eventually get so lost that you're overwhelmed. And I think that's one of the biggest reasons why 1 and 2 kids end up failing first year calc. And I don't want that to be you. So I need you to start building those skills now. Stay on top of things. If you were watching these videos in like the 3rd week of our 3-week set, if like the assignment is due later this week, shame on you. You are not doing this properly, and you should know better, and I've been telling you to do this better. So you need to make sure that you watch all these videos well in advance so that you have time to process, time to answer questions, time to have me look over your assignment, time to do practice out of the textbook on your own as extra supplemental stuff. Not because it's due, but because it's good for you. Okay? These are the skills and habits that you'll need. Okay? And you can take my advice as someone who's been here and done that, and someone who's taught plenty of kids who've gone through this. Or you can think, no, I've got this on my own, and figure that you're going to be that 1 in a million kids who doesn't need to follow the process. And maybe you will. Maybe you will. But I want to try to encourage you with good advice. So that's my advice. Stay up to date. Do this on a daily basis. Find extra practice out of a book. Don't just do your assignments. Don't do them at the last minute. Don't skip class. Don't procrastinate. These are all things that you've known how to do since like grade 4. But it's hard when you become when you have to start adulting for the first time. Life gets in the way. But yeah, that's my hope, is that I can help you, at least show you what you need to do in order to do well. So, okay, that's our lesson. It's actually quite short. Quick summary then. There are 4 rules you need to know. Here are the 4 rules. If you know how to use them, you're good to go. It helps even more if you understand the basics of how they were discovered, but I imagine that if you didn't watch the first 2 videos and I showed you this, it's going to look like gibberish, because you're going to be like, what the heck is E? What the heck is B? And you might think, oh, okay, well, they're just numbers. Well, B is 2 or 3 or 4 or 7 over 12. But E is its own number. E is a number on its own. And that E helps you actually get this ln notation, because otherwise you might think, what the heck is ln? So here's our 4 derivatives. Hopefully you are somewhat familiar with them. If not, rewatch these last 2 lessons. But maybe more importantly than that, let's talk over VC, over in person if possible. If you're in my school, I don't really care how, but you need to get more one-on-one help if you're not getting the marks you want. Okay, that's going to be the first thing you have to do to improve. So, okay, I'll call her quits there. We've got one last lesson, and then you have an assignment that's due. And I'm not accepting late ones, right? We talked about late assignments in the past. Make sure that you're on top of this. So, okay, we'll talk to you guys later.